So I had a request for some help on this. Are you ready for Math 141? So I want to start off by going through and just making a video of some hints on how to get started, because sometimes people are just blocked up from that. You need to get over a hump. So this video should help you with that without directly giving it away, hopefully, and kind of prompt you through some tips of how to start. So first of all, with this number 1, x minus 3 over 5 minus 1 equals x minus 5 all divided by 4. So we want to get rid of the fractions. If we ever have more than one fraction, it's really a nice technique to use what we call clearing the denominator. So I'm going to look at my denominators here. I have 5 and a 4, and this is as if it's over 1. If you tend to forget to do the whole number, deal with the whole number term, you should just put it over 1 so that you clearly see. So you need to multiply both sides by the LCD, which is going to be 20. So you just look at these numbers and figure out what they both divide into, so that way they'll cancel out to 1 in the denominator. That's our goal. So if I were to balance, I can do this with the equations because I can balance, because I can multiply both sides by 20. I can't just do it with an expression that doesn't have an equal sign. The only other time I can do this process, this clearing denominators, is if I have a fraction. I have a complex rational with fractions within fractions. So I'll show you one of those as well. So to get started with that, we want to use that technique of clearing the denominator. And you've got to be a little careful. You've got to distribute this 20 to every term. So you have 2 terms in there. So how it's going to play out, I'll write it, we would have 20 times x minus 3 over 5 minus 20 times the 1. A lot of times people forget that. And then 20 times the x minus 5 over 4. And it's important to use parentheses. Then we would go ahead and reduce where we can. So we would have 20 divided by 5 is going to give us 4 there, and this one's all set. Then I would have this 20 over 4 becomes 5. Now you can just kind of do it here. What I actually do is I kind of squeeze in, like I'll just go, okay, I'm going to multiply every term by 20. So I kind of squeeze it in like that, and just know I have to hit every term, because eventually by distributing I'm going to do that, right? But I'm writing it out here to give you a little more tips. Then from here, you can just clean it up. Again, depending how familiar you are with these and how fluent, you don't necessarily have to rewrite this step, but that should get you started. Now it's just a regular, straightforward solving an equation. One thing you have to note, if you have variables in your denominators here, you have to make sure you test out and check your domain, okay? So if these were variables, I would have to avoid any kind of undefined answer in my final solution. So, but I'll let you finish that out, but you can try this on your own and then see if you get that first step. Okay, so that's just number 1. Number 2 is similar over here, but we have some fractions outside parentheses, so you need to be careful not to double dip. A lot of times people will think they can go like, if I were to multiply by the LCD here, they want to multiply by this, then this, then this, but we never multiply over or distribute over multiplication. So for example, if I had 3 times 2 times, let's just do something easy like, 4 or something like that. There's a couple of different ways you could do that. You could actually just multiply 3 times 8 use your associative property and get 24. But you also could just do this 3 times 2 times 4. You could just go 3 times 2 is 6 times 4 would be 24. Really, we're reassociating differently. What you wouldn't want to do, you can see how this wouldn't work out if you went and had something like 3 times quantity 2 times 4. If you distributed twice, like you went or multiplied twice there, so 6 times 12, that would not come out to be the same answer at all, right? We would get 72. That would be wrong. So we call that, we don't distribute over multiplication. We only distribute over if there's a plus or minus. So once we hit here, this is considered a multiplication operation. So when I go ahead and do that clearing the denominator technique, I have a 2 and I have a 6. So I need to multiply both sides by the LCD, which would be 6 in that case. If you kind of get confused with how this whole business works over here and you tend to sort of distribute over multiplication, then you can just distribute ahead of time over the plus or minus. So here, if I multiply both entire sides by 6 or the entire equation by 6 and then distribute, but I'm only going to distribute to these, each term. This is considered an entire term. This is one term, this is a term, and this is a term. Okay, this is my separation of plus or minus. So when you do that, you should end up with, this will become a 3. So you're going to end up with a 9x plus, well, I'm just going to rewrite the whole thing first. So this will end up with being a 9 times x plus 2. This will end up being, get rid of that, a 1 times x plus 2 there. And this will be 6 times 2 plus 6 times x. So you can distribute that way and end up with 9x plus 18 plus x plus 2 equals 12 plus 6x. So that's one method, and if you're used to this and used to seeing this, I would say just go for it. That's how I'll do it. It's quicker in general, and I usually would just kind of leap down here. But I'm going to go ahead and erase all this, and if you struggle with that, of course you would finish this out as a regular solving to complete the problem. But if this is something you're not that familiar with, I'm going to show you just a little bit different way to set that up. So what I could do is actually distribute these first. That might just be a little cleaner for you. So you would have 3 halves x. Then actually some things naturally get reduced. So 3 halves times 2, that's like a 2 over 1. The 2's would cancel out. So I would just be left with 3 there. Then I would have 1/6 x plus 2 over 6, which is 1/3. I mean, you could just leave it as a 6 for now if you want, 2/6, but, and then 2 plus x. Now I can use my clearing technique, and I'm going to multiply every term by 6 all the way through. So I'm just going to show you how I write it out. Like, if I were to distribute, I would be multiplying every term separated by the plus or minus here by 6. Okay, so you can think of it that way. It's basically you're multiplying both sides by 6, keeping your balance. which makes, or just the whole equation by 6 gives you a multiple of that equation, so there it's equivalent. You're not changing any values here, you're just reformatting. And then I've distributed. So now I'm going to have a little cleaner operation here when I go to cancel everything. So this 6 over 2 would be 3, so I get my 9x plus 18. The 6 is reduced to 1x. Don't forget to write your variables in there too. Sometimes it gets a little lost. And then the 6 over 3 is my 2. I don't need to write that one actually. And then equals 6 times 2. It's going to be my 12. 6 times x is 6x. So that actually might just be a little bit cleaner for you. And so this is where you would finish off, combine your like terms, you solve out, and then make sure you can know how to check answers. I don't usually require it at this level, but make sure you know how to double check that. So that goes over a couple of different ways of clearing the denominator type problems. So you of course would finish it out, and if there were variables in the denominators, we'd have to be careful. Now we're going to look at number 3, x minus 3 all squared equals 50. So my quad is already isolated, so I can actually just go ahead and take the square root of both sides. I don't need to expand this out. It's really set up nicely for me, so I'm going to use the square root method. So I take the square root of both sides, and then I would, the square root of something squared, right, is going to be just the inside part, the radicand, and then equals square root of 50. I would have, I want to break that down to simplest radical form. So again, I could write 50, I'm going to write it off to here as 2 times 25. Square root of 25 is plus or minus 5. And then I'm left with the 2 in there. So from there, you should be able to finish that out. Just add 3 to both sides, and that's done. Okay. Number 4, you would have this radical. Really the best route to go on this one is to set it equal to 0 and factor. That one's factorable. If you aren't sure if it's factorable, you know, especially because you have a coefficient, lead coefficient that is not 1, but it is prime, so it's not too bad. But hopefully you can recognize if things are factorable. Sorry about that. Sometimes my hand hits the zooming. Try to cover that up. So you're going to set it equal to 0. 3x squared minus 11x minus 4 equals 0. Just watch your signs there, and then that is factorable. And usually with quads, they're both going to come out. It's not an application, so I would say one or the other, and or the other. But remember, or in math often means and or. So number 5, the only way to deal with this one is to first expand it. So you're gonna just FOIL this out. I think you had one similar to this in your homework. So you can do a variety of things, but I'm just going to start you off x squared, and then I have the 3x plus the 5x's plus 8x. A lot of times here in this course you can streamline those kind of steps. And then equals 4. And I'm actually going to do completing the square for this one. You could use quadratic formula. You could set it equal to 0, but I think a lot of times people are kind of shy of completing the square. That's where quad formula stems from anyway. So I'll just kind of review that technique with you. So I would want to get these variable parts equal to a number on the other side. So I would subtract 15 from both sides. So I end up with x squared plus 8x, and then I'm going to leave a little space here. And then I have 4 minus 15 gives me negative 11. So to complete the square, then I can use the square root method. So what I do is I would have this middle term, you want to add b over 2 squared to both sides. Okay, so we need to figure out what that is. So if our b is 8, I would add 8 over 2 squared. Now I'm writing that out that way so you can clearly see, but what I would actually, and how I came up with that number, what I would actually do is not write it that way. I would divide it out. I can simplify this. Sometimes I can't though, so that's why I wanted to show you. But 8 over 2 becomes 4, and then squared is 16. So I would just really write it like this. I would add the 16 to both sides because I have to balance, right? So then I end up with factoring this. It's a perfect square trinomial because that's what I created. That's the whole purpose of completing the square. X plus 4. Sometimes you learn just like rote learning and you don't know why, but this is why, because I want to pick a number here based on the b value so that I get it to factor as a binomial squared. And if you were to FOIL that out, you would get the 8 squared plus 8x plus 16 back. Now be careful here too, we don't distribute exponents either. We would have to have that middle term. You have to expand the whole thing out. Okay, because that's really like x plus 4 times x plus 4, right? And then you would have to distribute first, outside, inside, last, right? And have a middle term in there. And that's how we get that 8x. Just to recap that a little bit, that's kind of what this video is about here. Getting you refreshed on those kind of building block things that might stop you up from getting going on your problem. So now this presents just like the one above. So I'm not going to do that again. We've done one like that. And you would just take this square root of both sides and carry on. Number 6 is a clearing the denominator, but we do have to note that we can't have our x equal to -1 because that would give us an undefined situation there. So what I'm going to do is multiply every term, kind of talked about the concept before, but by the LCD. So the LCD in this case involves variables. So it would be 2 times x plus 1, 2 times x plus 1. I mean, of course I'm going faster with this because it should be reviewed, but again, even if you just took Math 99, like these are kind of tricky problems. So these rationals always present sometimes times some grief for people. So we want to go through it. So then I would reduce my x plus 1 over x plus 1. So that gives me 2 times 3, 6 there. Subtract. And then I have the 2's cancel out. Now make sure you use your parentheses here. I'm actually going to even write it like this. X plus 1 times x minus 2 and like that. Just so we're real careful and we know that negative is going to distribute. That's another common mistake that trips people up a little bit there. And then the last one, don't forget to do the other side. You would have x minus 2 times 2. And that 2 could go on the left or right. It's fine. And then what I have to do is clean this up. Again, parentheses, I'm going to FOIL this out. I'm going to do it really pretty quickly. You could do more steps if you want, but I just kind of do it the middle term in my head. And you're probably pretty familiar with that by now too. And then the key thing is, see, this negative has to distribute. So for this problem, you should end up with 6 minus x squared plus x plus 2 equals 2x minus 4. And then you're going to simplify from there, set it equal to 0, and then it is factorable. Okay, so we'll just write a little note here. Simplify each side, set equal to 0, and factor and solve. Okay, and then check your answer. Make sure if you ended up with a -1, you have to exclude that from your solution. You would just write it's extraneous because it causes an undefined situation. So for number 7, we have a very similar problem. I'm not going to go through that one. You would use the same technique as you used for 6. So I'll just write that. For 8, we have a radical, so we're going to actually square both sides. Our radical's already isolated, so we go ahead and do that. And so I'm just left with 2x minus 6 equals 36. And you can go ahead and solve that fairly easily. You do have to check your answers back in to make sure they work out for both sides. Okay, so for number 9, it's very similar to the one the radical one we just did. Okay. One thing I want to point out for number 7, you are going to get one answer that's extraneous, that it cannot be equal to. And also for number 9, you're going to get an extraneous answer, because we have to note here on number 7, x cannot equal 3. For the radicals, you really just need to check them. You need to test your answers. I think I've shown that in the examples for the class problems, though. So this one's set up almost there, but you have to subtract 8 from both sides and then square. So I'd have square root of 2x, whoops, minus 8 in a radical, right? Equals x minus 8. Now this one's a bit trickier, a lot trickier, because when you go ahead and square your radical, you are also squaring the right hand side is an expression, so you have a binomial there. So 2x minus 8 is the square. Once you square that, you just end up with what's under the square root. But then here I have x minus 8 squared, all squared. Remember, you can't just distribute that. It's really like x minus 8 times x minus 8. And if you were to do that out, you're going to get x squared minus 8x minus 8x plus 64. So it comes out to be x squared plus 16x plus 64, perfect square trinomial. So be very careful of that. Then you're going to just set equal to 0. It actually will factor and will solve. And then don't forget to test answers back in original. And I'll show you one of them. So one of the answers comes out to be 6. And so I'm going to test that up here. I'll just show you where I have some space. So I would test 6. Okay, because I know the answer is going to come out to be x equals 6 or x equals 12. Then I'm going to test 6 first up here. Okay. And then I'm going to test 12. And I'm going to tell you, I know this one works out and this one doesn't, right? But I'll show you why it doesn't in case you're not familiar with that process. So we have square root of 2x minus 8 plus 8 equals x. So we're going to fill in our 6 there. We're going to get a square root of 2 times 6 minus 8 plus 8 equals 6. And let's see, we're saying, is that equal actually? So we have square root of 12 minus 8 is going to work out for us as a 4, and then plus 8, does that equal 6? So then I end up getting the square root of 4 is 2 plus 8. Does that equal 6? No, it doesn't. We can test 12 to show you, but that makes this be extraneous. I think I'm going to do this in another video, so this one's getting kind of long. So I'll just show you, I'll test the 12 just so you see how to test. So now I would do my square root of 2x minus 8 plus 8 equals x. So I'm going to plug my 12 in here. Square root of 2 times 12 minus 8 plus 8 equals 12. Or does it equal 12? So I would have 24 minus 8 plus 8. Does it equal 12? I would have square root of 24 minus 8 is 16 plus 8 equals 12. 4 plus 8 equals 12. Yes, it does. So 12 is good. And the reason that happens is sometimes, you know, when you're manipulating and you're squaring something, there's going to be the oddball answer, because we're just, you know, kind of looking at the primary roots there. So always test when you have a radical like that. You have to test when it's when you have something, a variable in the denominator, you have to test. What you're doing is checking the domain here, because if I tried to put, you know, 6 in there, it's not going to work out as a proper domain. It doesn't give a true result. The same thing with when you end up with values that cause a undefined situation in a fraction, then they're no good. Okay, mostly everything else is just fine. Okay, so I'm going to stop this one here. We'll call this part 1 because they're all pretty similar, and then the last part of the page is tricky. And I do have the full solutions for you to see, but I wanted you to kind of have more explanation and how to get started, because I think once you get to these certain points, it's just a matter of solving and you're good. But it's like, how do I get that initial thing going? So ask me questions if you're not clear on anything I said, and I can help clarify that or work with you individually. Have a great day.